Okay, this is the second part of correlations. In previous class, we have studied about the overview of correlations in first part. So today we'll start with another part of correlations. In this part, we have to understand the mathematical representation of correlations, and by using this, we will solve real life examples in correlations with different types of methods. So x dash equals to x minus 10 divided by 4 and y dash will be y minus 12.5. Actually, this 10 comes from what? From assumed mean. Assumed mean of the rows. This what will be? Mid values of this? Every mid values where? 2, 6, 10, 14. Okay, mid values. So taking assumed mean this. And according to the column, mid values what will be? 12.5. Okay. So the deviation number, just putting individual y, we get -2, -1, 0, 1, 2. Okay. Now frequency given 7, 6, and this is the frequency 857 and 3, 2, and frequency only 9 here. Okay, there is absent, no frequency. So just putting that columns. Okay, frequency this first column, then next column, and then another column, and there will be just 9. All are absent without values. So summation f what will be? Summation f total 7, 6, 13, and total frequency what? 20, and here total frequency 5 and total frequency only 9. Individually here summation f according to the row wise only 7, and 6, 8, 8 will be what? 6, 8 what? 14, and 0, 5, and 3 what will be? 8. So according to the row wise we get this sum of frequency total will be 47. In here total also 47. So fx dash frequency multiplied x dash what? -2 multiply 7. Okay, -2 multiply 7 minus 14, 7.5 minus 1, 7.5 multiply 6. Okay, y dash, and this will be y dash whole square. Okay, now fx dash will be according to the x dash values multiplied with frequency, you get this, and making a x square dash x square means what? -2 whole square multiply frequency 7, what will be? 26. Okay, only 7, 26. So this will be what? -1 multiply what? 20. Okay, -1 multiply 20. So 0 multiply 5, so 0, and then 9 multiply 1, so only 9. So x dash whole square into f. X dash whole square means what? -2 whole square into 13, 52. Okay, then x dash whole square -1 whole square multiply 20. Okay, then we get only minus plus 20. So this will be 0, and -1 whole square multiply 9 will be this 9 will be only 9. Similarly, f x dash y dash means x dash, this is the x dash, and this is the y dash means individually. This multiplied with frequency 2 to 4, this will give total fx dash y dash. Okay, similarly row column wise we get this table, just taking some, making sum to this all columns, we get these values. Now putting in the formula of correlations, coefficients are equals to this. This is the actually shortcut method. Now putting all the values from the tables, we get the correlation coefficient values 0.87. This is actually positive correlation and very perfect correlation. So this is our desired result is very valid correlation for us, and this coefficient is very perfect also. Can you do this example? Okay, now effect of change of origin and scale. Uh, will verify this whether it will change the origin or scale. Let the origin and scale of xi be changed and new variate ui be is defined as like this. Ui equals to what? Xi minus a divided by a is. Actually, a is the origin, that means assumed mean. Okay, a equals to what? Assumed mean. Where a is the origin and a is the scale, length of the class interval, right? For group data, a will be the scale of the variate xi, and similarly bi equals to y for y values yi minus b divided by k, where b is the also origin or assumed mean for y data, and k is the length of the class interval for y data. So so that we have xi equals to what will be just by cross multiplication, xi equals to is ui plus a, and if we take x bar, that means mean, on mean x bar equals to what will be s into u bar plus a. Similarly, from y data for y variables, we get yi equals to k bi just by cross multiplication, yi equals to k bi plus b. So taking mean, y bar equals to what will be k b bar plus b. Now putting these values xi, x bar, yi, y bar in equation, that means in the correlation coefficients of, this is the correlation coefficients. This is the formula of correlation coefficients. Okay, just putting these values, we get this. Where the 9.1, actually 9.1 is this. This is the correlation coefficient between x and y. Rxy equals to what? 1 by n summation xi minus x bar yi minus y bar divided by square root over 1 by n summation xi minus x bar whole square. This is the standard deviation. Okay, variance whole square. Okay, this is also square root, that means variance whole square on for y. So this is the formula, and putting xi, yi and x bar, y bar values in this equation, we get this equation. Okay, just putting the values, then we can write sk here, sk, and sk will be square root over this sk, this sk will be cancelled. Okay, this sk and this sk will be cancelled, and this will be also cancelled, and this will be also cancelled. So this can be written as, this formula can be written as rub. Okay, sk will be cancelled, rub. Okay, this equals to what? Correlation coefficient of u and b. That means rxy equals to, we have proved that RUB. That means correlation coefficient between x and y is equal to correlation coefficient of u and b. Understand? So in this case, we can decide if a k are the both positive, we have correlation coefficient of x between x and y equals to correlation coefficient between u and b. That means these are equal, which indicates that correlation coefficient is independent on changes of origin and scale. That means that does not, there is no effect of origin and scale. Okay, the method of this type is calculation is called shortcut method. Understand, everybody? This is called shortcut method, and we have proved that there is no effect of change of origin and scale on correlation using these two variate. Okay, ui and bi. This is two variate. Ui is the variate of xi data, and bi is the variate of yi data, and using this variation, we and putting these four values in the correlation coefficient of xy, we got the correlation coefficient of ub equal. So there is, in this term there is no s and Okay. This is why ace means what? Scale. And k is also scale. And a and b what was? A and b origin. This is why there is no effect of origin and scale. Now, limits of correlation coefficients you must know from previous lecture. The correlation coefficients between x and y takes values -1 to +1. That means correlation coefficient between x and y lies between -1 and 1. We are proving this result. Let us consider xi minus x bar divided by sx. This is the standard deviation of x data, and yi minus y bar, okay, y bar divided by sy. This is the actually standard deviation of sy, what? Standard deviation of y data. And if you make this square, actually this becomes squared. Okay, this will be must be positive and maybe 0. So this will be non-negative. Okay, because square of any numbers can never be negative. We must know from our early age, from our first, everybody knows that square of any numbers, maybe negative numbers or positive numbers, square of any numbers will be must be positive. So we can write this expression, this square equals to non-negative. Okay, maybe 0. Okay, so this must be, this is the square term. This is why this term will be must be non-negative. So a plus b, this is plus minus here. A plus b whole square formula you must know, or a minus b whole square formula. A square minus 2ab plus b square, or a square plus 2ab plus 2ab plus b square, like this. Okay, just making this formula, we get this. Here for plus and here are minus. This will be non-negative. Now taking summation over the entire range of xi, because xi is the variables. There will be must be a range, and yi also another variables. So we are discussing about the correlation between these two variables x and y. So taking summation on both sides, we get summation this, and 2 into summation this. Okay, this product, this must be what? Non-negative. Okay, so according to the formula of standard deviation, or according to the definition of a variance, okay, and sx whole square, sx whole square means actually variance. Okay, sx whole square. So n into sx whole square, this will be the formula, and n into sy whole square, and this is the actually product of what? N sxy, covariance. Okay, this is called covariance formula. Now sx whole square, and there sy whole square, and this is sx into sy, just multiplication, will be non-negative. Okay, now dividing by n on both sides. Okay, and sx whole square will be cancelled. This will be cancelled. This will be this is the actually sx divided by sy. This is the actually formula of correlation coefficient between x and y. Understand? We have used this since sxy divided by, this is the covariance of xy divided by variance of x, standard deviation of x and a standard deviation of y will gives the correlation coefficient between x and y. Understand? So we have proved that 1 plus minus this greater equal to 0. That means this inequality can be written as 1 minus 1 less equal to rxy less equal to 1. Hence proved. That means correlation coefficient between x and y must lies between -1 and 1, and cannot be greater than 1 and cannot be less than -1. Okay. Okay, now try to solve another problem. Calculate the correlation coefficient between heights of father and non and son from the following data. Height of father this, and height of son will be this. Actually, correlation and regression analysis are a little bit different here, but there is a relationship between this. First of all, we are studying correlation. So father father will indicate be x variable and son will be y variables. Understand? Just taking x square means this square, and y square means this square, and xy means for just multiplication individually. Okay, we get this column. Now u equals to what? Variate. U variate will be x minus x bar. X bar means what? X bar means what? Assumed mean. Taking assumed mean, this is the 68, and another assumed mean is 69. Okay, this is the serial number. So we can take 68 as the assumed mean, and here 69 as the assumed mean. Then u equals to this and b equals to this. U square this and b square this, ub equals to, we get 20. So we know from the formula of correlation coefficient between x and y will be using this formula. Using what's formula actually? Do you know? Using this formula, correlation coefficient of xy equals to summation xi yy minus summation xi summation yi divided by n square root over summation xi square minus summation xi divided by n. Okay, this whole square. This is the y standard deviation. And using this formula to this, we get rxy equals to this, and this value actually we get after calculation by using calculator, we get 0.67 approximately. Okay, similarly from another RUB means what actually? RUB means what? Correlation coefficient between u and b. Just putting the values we get 0.67. Similar process. Therefore, shown in numerically that rxy equals to rub. Understand? We have proved it in previous. We have proved this. Okay. RU okay. Rxy equals to rub. We have proved numerically here, and theoretically we have proved in this effects of change of origin of and scale. Okay. So in numerically we have proved that correlation coefficient between u and ub and correlation coefficient between x and y are equal, and this is the positive correlation. So we can say that this is the perfect correlation. Okay. The similar process you can proceed. Calculate the correlation coefficient between the ages of husband and wives given in table in previous examples table. We can tabulate it like before examples. Okay, this is homework for you. I hope everybody can do this because we have done 2 or 3 examples in our previous lectures. Okay, this will be homework for you. Understand everybody? Now example 9.3. If x and y are independent variables, show that they are uncorrelated. We have to prove this. This is the theorem. Since x and y are independent, we have covariance of xy. What will be? Expectation of x minus x bar, y minus y bar. This is the actually formula for covariance according to the definition of expectation. So expectation of x minus x bar, y minus y bar can be written as expectation of x minus x bar, expectation of y minus y bar will be what? 0. Because covariance of xy equals to 0. We know correlation coefficient between x and y are equals to, that means are equals to what? Covariance of xy divided by variance of x into variance of y. Using this formula, r equals to 0. That means we have to observe that this r will be 0 when covariance of xy equal to 0. According to the definition, r will be 0. So we this proved that x and y are uncorrelated. That means there is no correlation because r equals to what? 0. Now the converse of the result is not necessarily true, but the converse means what? If r equals to 0, covariance equals to, if r equals to 0, x and y are independent. This may not 0, may not true. Okay, if r equals to 0, that means the vice versa. If r equals to 0 and x and y are may not independent. Understand? This is the actually proof, necessary condition. If f of x y equals to half, x lies between -1 and 1. If y equals to x square, then expectation of x, by using this formula, we get 0. But expectation of x into expectation of y equal to 0. Further, expectation of xy will be expectation of x cube, same word, because y equal to x square. This is why xy equals to x cube. Uh, after taking integration of this, we get 0. Hence, covariance of this will be 0. So r equals to 0. That means x and y are uncorrelated. However, for each values of x, there are only one possible value of y, and for each value of y, there are only two possible values of x. Therefore, x, y are far from being independent. That may not be dependent, may be dependent. Okay. Now we'll try to calculate the rank correlation of a Spearman. Spearman rank correlation coefficient correlation are equals to 1 minus 6 summation d square and into n square minus 1. Now we'll try to prove this relation. This is the actually rank correlation for Spearman. Understand? Rank correlation. Let x1, y1, x2, y2, dot x and yn are be the rank of individuals corresponding to characteristics. Understand? Assume not two individuals are equal in either classification. That means two individual men will be not equal. Each individual takes the values 1 to n natural number. Okay. Hence, their arithmetic mean will be arithmetic mean summation n divided by number of frequency. That means number of frequency of this what? N. So summation n what? N into n plus 1 by 2. Sum of n natural number what? N into n plus 1 by 2. This n will be cut, n plus 1 by 2. Now let x1, x2, x3 dot xn be the values of the variable x, and y1, y2 dot yn will be the variable of y. So deviation variate d will be x minus y. X minus y can be taken as x equals to what? X minus x bar. Okay, and y will be y minus y bar. You must know about this. Capital X equals to what? X minus x bar. X bar means what? This. Y bar or same. Okay, same natural number. This is y minus y bar. This means actually n plus 1 by 2, n plus 1 by 2 will be cancelled. So x minus y. Now where the x and y are deviations from the mean, summation x square what? Summation x square. Summation x means what? X minus x bar. Okay, x bar whole square. This can be written as a minus b whole square formula. A square minus 2ab plus b square. 2 cancel and only ab will be exist. So this is the b square n plus 1 by 2 whole square. So this summation x square means what? Sum of a square of n natural number. That means 1 square plus 2 square plus 3 square plus dot plus n square. That means n into n plus 1 twice n plus 1 by 6 minus, and this n plus 1, and this summation x means what? X equals to what? 1 plus 2 plus 3 plus dot. Okay, 1 plus 2 plus 3 plus dot n. So sum of n natural number what? N into n plus 1 by 2. And this summation n plus 1 by 2 whole square. How many n plus 1 by 2 whole square here? Actually n number, because there are n number of frequency. So n into n plus 1 by 2 whole square. Now just taking LCM and taking common n plus 1 by 2, we get this result. Understand everybody? Clearly summation x equals to summation y, and summation x square equal to what? Summation y square. Okay, summation y square can be written as summation y square and summation x square same. Okay, same. So summation y square will be n into n square minus 1 by 12. Now summation d square what will be? D equals to what was? D equals to x minus y. So summation d square what will be? Summation x minus y whole square. And this will be, can be written as x square plus minus 2ab plus b square. minus twice ab plus b square. So summation xy equals to half summation d square equals to what? Summation x minus y whole square equal to a minus b whole square formula. Now summation capital XY what? Summation capital XY what will be? Half into n into n square minus 1 by 6 minus summation d square. Summation xy equals to. So multiplying half we get this. Now putting these values in are equals to summation xy square root over summation x square and summation y square, just putting these values we get this. This is the actually Spearman rank correlation coefficient. Okay, and n is the number of frequency and d is the difference between two deviation. Okay, deviation of variables, variate, and this is the formula for Spearman rank correlation. We can solve this by another method actually. Actually, this is another method for you. Actually, sum of n natural number 1 comma 2 comma dot dot n. This is the x bar equals to y bar equal same 1 plus 2 plus dot dot plus n, then divided by total number of frequency we get n into n plus 1 by 2 into n. That means n will be cancelled. So x bar and y bar equal to n plus 1 by 2. The standard deviation formula what? This 1 by n summation xi minus x bar whole square, and this can be written as what? 1 by n summation xi square minus x bar whole square. Okay, this can be written as like this. Now 1 by n summation xi square what? 1 square plus 2 square plus dot dot plus n square. And x bar whole square means what? X bar means what? This 1 plus 1 by 2 whole square. So this series, this is the sum of this series will be n into n plus 1 plus 2 n plus 1 by 6. Now taking common n plus, this is the n plus 1 by 2 whole square. So n plus 1 by 2 can be take common, we get this, and then n square minus 1 by 12. This is the sx whole square. That means a standard deviation of x variables. This will be equal to what? Standard deviation of y variable, same. Okay. Now let di equals to what was xi minus x yi. That means xi minus x bar minus y minus y bar. Similarly, squaring and taking summation summation di square, what will be? This sum of this whole square. Okay, summation this minus this whole square. This means what? A minus b whole square. Okay, a square minus 2ab plus b square, same words. Now dividing both sides by n, we get summation di whole square divided by n. Okay, dividing by n on both sides. This will be dividing by n. This will be a standard deviation of x variables, and this is the standard deviation of y variables, and this is the covariance of xy. Okay, that means after dividing by n, we can write this is the sxy. Okay, now sx whole square plus this is the sy whole square. Sx whole square and sy whole square are same. Okay, same standard deviation for x variables and y variables. Okay, same standard deviation this was, and this x whole square and sy whole square. So they are same standard deviation. Now from these relations, using sx whole square equal to sy whole square, we get 2sx whole square 1 minus r equal to 2 into this 1 minus r. Sx whole square means values this 1 minus r. So r equals to this. This is the another method for finding Pearson's rank correlation coefficient. Okay. This example, the rank of 10 students in mathematics and students are as follows. Find the rank correlation coefficient. Okay. Mathematics rank this, and statistics ranks are given. Okay, so ranks in maths are given this, and ranks in y this. just taking difference between them. Okay, taking difference. 3 minus 6 will be this, 5 minus 4 will be this, 8 minus 9 will be minus 1, 7 minus 8 will be minus 4, and taking this summation di equals to what? 0, and this will be di whole square. Okay, that means squaring this, we get this, just making a square, we get total number 214. Now rank correlation coefficient will be r equals to 1 minus summation di whole square, and will be what? 10 students. Okay, 10 students, then we get minus 0.3 approximately. Actually there are uncorrelated, negative correlation, there is no relation between two variables, math and statistics. Okay, compute the Spearman rank correlation coefficient R for the following data: person A to Z, and rank in statistics are given this, and rank in income are given to this. Okay, now Pearson's person will be A to Z, then rank in statistics 9, 10, 6. Okay, and rank will be in income will be this. So d equals to what? Just difference, taking difference, and some square, making a square this individually, we get some summation d square equal to 280. Just putting these values here, we get minus 0.697. That means there will new equal ranks. Understand, everybody? Now obtain ranks correlation coefficient for the following data. Actually, there will be repeated ranks, and for the repeated ranks, we have to modify the rank correlation like this. Formula will be r equals to 1 minus 6 into third bracket summation d square 1 by 12 m1 is the repeated term, repeated rank, first repeated rank m1, and second repeated rank m2, and third repeated m3 in this way. Okay, and in the denominator will be same. Now this is the x values, and there are the y values given here. Okay, first of all, this is the x variables and this is the y variables. Now rank of rank in x will be how? Actually highest value here, what can you say? Highest value 80. Okay, highest value is 80, so we'll give rank 1. Understand? Then after 80, which is the highest value here? Which will be the highest? 75. Okay, this is the 75, and this is the another 75. So how many 75 here? 275. Okay, so there are this rank may be 2 or these 3, so rank 2 and 3 are given to 75, both of 75. So there are 2 plus 3, rank will be what? 2.5. 2 plus 3 equal to 5, total rank what? 5. This is why we have to divide this rank to give both them. That means this 75 will get 2.5, and this 75 will get 2.5. Now another after 75, which is the largest number? 68. Okay, how many 68 here? Actually only single 68. So this rank will be what? Rank 2 and 3 are used. Okay, for 2 and 3 are used for what? 75. Now the rank of 68 what will be? 4. Okay, 2 and 3 used for 75. This is why next rank what? 68, 4. Next rank 5. 5 will be for the next largest number. Next largest number after 68 what? What will be? 64. Actually how many 64 here? 264. So next rank what? 5 and 6. Okay, next rank what will be? After 68 rank, given rank 4. So next rank what will be? 5 and 6. Understand? How many 64 here? 164, and this 64, 364 here. So the rank 5, 6, 7. 5, 6, 7. Sum of 5, 6, 7 what? 5, 6, 7. Total 5, 6, 7 total what? 18. Okay, 18. So if you divide it into 3 parts, then we're dividing by 3, 18 by 3 what? 6. So this 64 will be 6, and this 64 will be 6, and this 64 will be 6. So 5, 6, 7 used. Now next rank what? 8. 8 rank will be after 64 what? Which is the largest number? 55. 55 will be rank 8. Now next largest number what? 650. 50 will be rank what? 9. Then the lowest number what? Most lowest 40. This is the rank 10 because 10 students here. This is the rank actually for X. Now rank for Y. Highest value what actually? 81. So rank will be 1. Next highest value after 81, which one? 70. So this will be rank what? 2. Next largest number after 70 will be what? 68, because there are 68. Understand? How many 68 here actually? 268. So rank 3 and 4. 3 and 4 are given to 68. But you have to divide this rank, sum of this rank. 2 and 3 and 3 and 4 sum equal to 7. Total rank what? 7. We have to divide it into 2 parts because 68 are 2 times. This is why 3.5 and 3.5 will be rank. So 3 and 4 used. Next rank 5 for 62. Okay, 5 for 62. Next 6 rank will be given to 60. Next number. Next largest number will be what? 58. So rank will be 7. And next largest number after 58 will be 50. This is why rank will be 8. Then after 50, largest number which one? 48. Rank 9. Then lowest number which one actually? 45. Okay, this will be rank 10. This is the repeated rank. Okay, and first repeated rank was for X 2.5, and next 2 times, and next repeated rank what? 3.5. So repeated ranks of X column 2.5. Okay, of X column, and 6 also given to 3 persons because here's 64 3 times. Okay, 6 64 3 times. Okay, and 2.5 2 times. This is why repeated rank 2 times, repeated row 3 times for X column, and this is the repeated rank for Y columns. 3.5 are given to, so M2 equals to 2, and M1 and M3, and this will be M2. Okay, now using the Carl Pearson's rank correlation coefficient R equals to 1 minus 6 third bracket summation d square plus 1 by 12 m1 whole cube minus m1 plus 1 by 12 m1 m2 whole cube minus m2 plus 1 by 12 m3 whole cube minus m3. Just putting summation d square is given by what? Just taking subtraction d, and this is the square, making a square every individually. We get sum what? Summation d square equal to what? 72. Just putting 72 here, and m1 equals to 2, m2 equals to 2 also, and m3 equals to 3. Okay, and using calculator we get 0.545. This is the actually perfect correlation coefficient between these two rank. Okay, X and Y. Okay, similarly find the rank coefficient, correlation coefficient to the following data. There is a first row is X for X and second row is for Y. Then we can assign the rank of the values X and Y. We have the table of the following form. This is the X column and Y column, and rank for X. Okay, similar process we can apply here. There's the what will be the highest value of this column? 71. This is why rank will be 1, and next 70, the next largest number will be 70. This is why rank 2, and then next largest number 69 will be rank 3. So next largest number which one? 68. How many 68 here actually? 2. So
2.
4 and 5 rank
9,
will be given to
divided by
68.
2.
Okay, 9 9 divided by 2, then that means 4.5 and 4.5. So next rank what will be? After 68, largest number which one? After 68, largest number will be what? 64. Okay. No, 67. Actually, how many 67 here? There are 267. So next two rank will be given to them after dividing with 2. Okay. That means we get repeated rank, first repeated rank 4.2 and 6.5 all for 2 for the X column. Okay. 6.5 given to 2 rank. So for the repeated rank of column Y column, this is the M3 and this is the M4 and this is the M5. Understand everybody? Because in Y column, largest number which one? Largest number 71. 71 will be rank 2, and next largest number what? After 71, 70. So rank 2 will be the rank for 70, and 69 will be rank 3. Okay. Now after 69, largest number 68. How many 68? 1, 2, 3, 4 68. Okay. 68 how many?
4.
4. Okay. 4. So rank 4, 5, 6, 7. 4, 5, 6, 7. What? Sum of 4, 5, 6, 7. Sum of 4, 5, 6, 7. What will be actually?
22.
22. Divide by 4. Dividing by 4, what will be?
5.5.
5.5. This 68. This 68 will get rank 5.5. This 68 5.5, and this 68 will be 5.5, and this is also 5.5. So after 68, which is the largest number? Which is 66. Okay, 66. Actually, how many 66 here? 260. 66. Understand? There are 66. Okay. So the next two rank will be divided into them. So this will be 9.5. Okay. Understand everybody?
Yes, sir.
Okay. So there are three repeated ranks: 9.5, 11.5, and 5.5. So M1 equals to M2 equals to these two repeated, and M3 equals to 2, M4 equals to 2, but M5 equals to what? 4 repeated, because 5.5 rank got 4%. Okay, 4%. This is why 4 M5 equals to 4. Now putting these values from table and repeated rank numbers in this big equation. Actually, this big equation is the rank correlation coefficient for R. R equals to what? 1 minus 6 into summation d square, and this term for M1 and this term for M2, same term actually, and this for M3, this for M4, and this for M5, and divided by same number. Okay. Now putting M1, M2, M3 and dot dot, and summation d square from what? Summation d square from last column, sum of this. Okay. And this difference between rank will be given by this d, and making a squaring, we get this, then taking sum. So we applying this table to this big equation, we get n equals to 12. Why? Actually 12 students here. Okay. This is why we get this big result, and big result gives 0.722. This is the perfect correlation between these two rank. Okay. There is a perfect correlation between these two rank. Okay, there is another example for you.
Sir, আজকের মতো শেষ করে দেন না স্যার, টাইম তো অনেক হয়েছে স্যার। 7
So this will be the next class, regression first part we will start. Okay. Till then,
Yes,
thanks to everybody.
Adab, sir.
This is the ending of correlation. Okay.
আসসালামু আলাইকুম স্যার।
Assalamu
Assalamualaikum,
Assalamualaikum, sir.
alaikum.
Adab, sir.
Okay.